Hello to all my viewers. This is Dr. Dhaval Maheta, and today we'll understand how to run parametric tests in STATA. Parametric tests are statistical methods that make assumptions about the population parameters, typically that the data follows a normal distribution. They are used to draw conclusions about population means, variances, and relationships between the variables. These tests are powerful when their assumptions are met, but can yield misleading results if applied incorrectly. Now, what are these assumptions? Let's see. The first one, data should be approximately normally distributed. Homogeneity of variance. Groups being compared should have a similar variances. Interval ratio data. Variables should be measured on a continuous scale. We start with the one sample t-test. In one sample t-test, the sample mean is compared with the known population mean. So this is a population from which sample is extracted. So the sample mean is compared with the population mean. Null hypothesis is there is no significant difference between the population mean and the sample mean. So to run this one sample t-test, first of all, we will download one data set. So go on Google, write down here HSB2 CSV. You will get openintro.org. Click on it. Now what this data is all about, it is high school and beyond survey data. 200 observations were randomly sampled from high school and beyond survey. A survey conducted on high school seniors by the National Center of Education Statistics. 200 observations and 11 variables are there. Categorical variables are gender, levels, female and male, race. It includes African, American, Asian, Hispanic and white. Socioeconomic status is low, middle and high. School type, public and private. Program is general, academic and vocational. The continuous variable is standard reading scores of the students. Standardized writing score of the students. Standardized math scores of the students. Standardized science scores and standardized social studies score. Now we want to download this data set. It's quite simple. Click on this CSV and the data will be downloaded on right hand side. You can see HSB2. Now how to import this data set? Go in STATA, go in File, Import, Text Data Delimited, *.csv, click on it, browse, click on downloads, click on HSB2, open, and you can see the data has been imported. Now press OK. On right hand side you will see the name of all the variables. Run the command browse, enter. So the name of the variable, gender, race, socioeconomic status, school type, program, and the continuous variables are reading marks, that is reading scores, writing scores, math scores, science scores and social studies score. So we start with the first test, one sample t-test. What is our research question? Does the average writing scores of students differ significantly from the national benchmark of 50? The null hypothesis is the mean writing score is equal to 50. That is HO, that is mu is equal to 50. Alternative, the mean writing score differs from 50. It's a two-tailed test. It can be more also and it can be less also. So alternative is H1 mu not equal to 50. Now we will check the assumption of normality. The null hypothesis for this is the variable right score is normally distributed. Alternative is the variable right score is not normally distributed. The command line is histogram right, comma, normal, and then we will do the formal testing with the help of Shapiro-Wilk test for the right variable. So let's go in STATA and write histogram right and we want the normal density curve. So here is it. But we will have to run the formal normality testing. So S wilk, right, enter, and we got the output. So here is a p-value. Now let's do the interpretation. As the p-value is 0.00004, which is less than 5% level of significance, we reject null hypothesis, which means that the right score is not normally distributed. Now in this scenario, we cannot carry out the t-test. We will have to go for non-parametric version. But for understanding purpose, we will proceed from here. So one sample t-test. Null hypothesis is the mean right score is equal to 50. That is, there is no significant difference in the sample mean and the population mean, or in other words, the sample mean is equal to the population mean. The alternative hypothesis is the mean right score differs from 50. That is a national average. So here mu is equal to 50, here mu is not equal to 50. What is the command line? T-test right double equal to 50. So let's go in STATA and run the command t-test right double equal to 50, enter, and we got the output. You will get three alternatives. That is a three alternative hypothesis. Mean less than 50, this mean not equal to 50, and mean greater than 50. So if your alternative hypothesis is one-tailed and it is mean greater than 50, the conclusion will be from here. If your alternative hypothesis is one-tailed in which mean is less than 50, your conclusion will be from this side, from the first one. But in case your alternative is mean is not equal to 50, it means that the results can be on both the sides. Our interpretation will be from the center. Just see the mean of the sample 52.775, which is tested against the population mean 50. And this is the value of t-test 4.1403. This output we can generate using the graphic user interface also, statistics, summaries, classical test of hypothesis, t-test. From here, activate the right, the national average 50, and press OK. And we got the output. Same output we will get. Now let's do the interpretation of this also. As the p-value is this one, is 0.001, which is less than 5% level of significance, we reject the null, which means that there is a statistically significant evidence that the average writing score differs from 50 national average. Now it can be on both the sides. It can be less also and it can be more also. But the positive t statistics, this positive t statistics and the mean 52.775 indicates scores are significantly higher than the 50. So the sample mean is higher than the population mean. Independent sample t-test. In independent sample t-test, means of two groups are compared. The score of section A with section B, department A, department B, process A, process B. Null hypothesis. There is no significant difference in means of two groups. What is a research question? Is there a significant difference in average math scores between male and female students? Null. There is no significant difference in mean math scores between male and female students. So HO, mu male is equal to mu female. Alternative is there is a significant difference in mean math scores between male and female students. So it's a two-tailed test. H1 is mu male is not equal to mu female. So we will have to test the normality. The normality hypothesis is the variable math score is normally distributed. Alternative is the variable math score is not normally distributed. So the command line is histogram math if gender double equal to male, histogram math if gender double equal to female. And then we will do the formal testing with the help of Sapir-Whorf test. So let's go in STATA. Histogram math if gender double equal to male, enter, and we got the output. This is a histogram for male. For female, recall the previous command by pressing page up and just write here female, FE, enter, and this is for female. Now we will run the Shapiro-Wilk test for male and female. The command line is swilk math if gender double equal to male, and we got the result, which is 0.10556 for male. Recall the previous command by pressing page up, and we will do the testing for female. So here the value is 0.195. Now let's do the interpretation. 0.105 and 0.195. As the p-value is 0.1056 for male and 0.1957 for female, which is more than 5% level of significance, we fail to reject null, which means that the math score is normally distributed, which is quite good. First assumption met. The second assumption, are the variances equal in both the groups, that is male and female? The variances of math score, are they equal in both the groups? So this is the plot of the equal variances, the normal distribution with equal variances. See their shapes, and this is normal distributions with different variances. We have to check this. So what is our null? Variances are equal across the groups. Alternative is variances are not equal across the groups. STATA does not have built-in Levin's test command, and therefore we are using the command robust variance, robvar math, comma by gender. So again we will go in STATA, robvar, enter, and we got the output female, male, and we do the interpretation from W50. So I have copied this. Let's do the interpretation again. Look for the W50 row, this one, the median based Levin's test. As the value for W50 is 0.460, which is more than 0.05, so we fail to reject null hypothesis, which means that the variances are equal across all the groups. This is also good. Both the assumptions met, and we can proceed further for independent sample t-test. Null. There is no significant difference in mean math scores between male and female students. Remember that this is the test for equal variance. Alternative is there is a significant difference in mean math scores between male and female students. So the first one, mu male is equal to mu female. This is mu male not equal to mu female. The command line is t-test math, comma by gender. So again we will go here, t-test math, comma by gender, enter. One tail, and the center one is two tail. As our alternative is two tail, our interpretation will be from here. So let's proceed further. It's 0.6801. As the p-value is 0.6801, which is more than 5% level of significance, we fail to reject null hypothesis that there is no significant difference in math scores between the gender. So in other words, null is accepted, but we write fail to reject. Now what does it mean? It means that the average of male is equal to average of female. The difference is not so large. This we can further confirm by just observing the female mean 52.39. So this is a math score, the average math score of female, and this is the average score of male. And just see the difference, it is very, very less. The difference is very less, almost negligible. Now in case if the p-value is less than 0.05, this one, we reject null, which means that there is a significant difference in math scores across the gender. If the difference is significant, mean math scores of male and female are reported. Now this is the case of equal variances. Now what to do if the variances are not equal? This scenario, this one. So what to do? No need to worry. The test proceeds further. The null remains same, alternative remains same, but we are introducing one more word, unequal, and this will run independent sample Welch test. This is for unequal variances. So again go in STATA, recall the previous command by pressing the page up and just write one word, unequal, and done. You got the output. So I'll copy this and let's do the interpretation of this. 0.6816, as the p-value is 0.6816, which is more than 5% level of significance. We fail to reject null hypothesis and conclude that there is no significant difference in math scores between the gender. In case if p-value is less than 0.05, this one, we reject null hypothesis and then compare mean math scores of male and female. Now, whatever output which we have generated with the help of command user interface, we can also generate with the help of graphic user interface. Go in statistics, summaries, classical test of hypothesis, click here, activate two samples using groups, click here, and then math score, and then it was gender, and click OK. So we got the output 0.6801, equal variances. Again go here, summaries, classical test of hypothesis, t-test, unequal variances. Click OK. This is for unequal variances. Okay, let's proceed further. The next is dependent sample t-test, also known as a paired sample t-test. So in a dependent sample t-test, means of the same group is compared before and after the treatment. See this, the sample remains same. We take the observation of the same person before and after, before going through the workshop and after going through the workshop. So what are the difference in their scores? Null hypothesis is there is no significant difference in means before and after the treatment. Research question and hypothesis. Do students perform significantly different on science and math scores? Null is there is no significant difference between science and math scores. You can also have a before the treatment and after the treatment, before implementing the policy, after implementing the policy. HO is mu science is equal to mu math. Alternative is there is a significant difference between mean science and math scores. The two-tailed test, so both the sides the possibility can be there. So H1 is mu science not equal to mu math. Now here we will have to do the normality testing of the data. The difference of science and math score is normally distributed. This we will have to check the difference of these two scores, and we'll have to create the new variable that is a difference. The difference of science and math score is not normally distributed. So let's generate this difference. Generate. It's a new variable which I am creating. Generate science minus maths. It is math. Okay. So here the difference has been created. Now let's do the formal testing of it by Shapiro-Wilk. So Shapiro-Wilk, and the name of the variable is difference. Enter. And we got the result 0.322. Let's do the interpretation of it. As the p-value is 0.322, which is more than 5% level of significance, we fail to reject null hypothesis, which means that the difference score is normally distributed, which is quite good. We can carry out the dependent sample t-test. What is a null? There is no difference in mean math scores and science scores in the students. So mu science is equal to mu math, and here mu science is not equal to mu math. What's the command line? T-test science double equal to math. And let's run this. So we will go in STATA. T-test science, enter. So this is one tail, this is one tail, and this is two tail. And the mean of science is 51.85, and for math it is 52.645. Now let's do the interpretation. As the p-value is 0.168, two tail, which is more than 5% level of significance, we fail to reject null hypothesis, which means that there is no significant difference in science scores and math scores. In case if this p-value is less than 0.05, we reject null, and then we compare the mean difference of science and math score. How much is this difference? Then we compare it. Now, whatever thing which we have generated with the help of command user interface, you can also do with the help of graphic user interface. So go in statistics, summaries, classical test of hypothesis, mean comparison, paired. So the first variable is science, and here the second is the math. Click OK, done, and the same result, you got the same result. See, 0.1768. So this was all about how to carry out the parametric test, that is a t-test in STATA. For more videos on STATA, kindly refer to my playlist. I have also uploaded many videos on data science, machine learning and artificial intelligence on my YouTube channel named Dhaval Maheta. To watch the full videos, please subscribe to my YouTube channel and check the playlist. Please don't forget to like and share my videos. You can also follow me on different social medias, link given in the description box.